Okay, clicker attendance. So let's see, we can start on that. Maybe. Let me mirror Zoom. I think I didn't do that yet. Not start. The same, maybe the same as the system. Try that. So you guys on Zoom, can y'all hear me? Oh, good. Yay. Okay. Awesome. Awesome. All right. So now I'm running a little behind, but that's okay. So check in on attendance. If you haven't checked in on attendance, please go ahead and do that. All right. And then I need my flash drive. Where is it? Come on. Here we go. I did iClicker and I need our problems. Okay, so what do you get when you cross an owl and bubblegum? An owl that chews wisely. I was like, please don't mess this one up. Please don't mess this one up. I'm not a really good joke teller if you haven't noticed. But at least it's a little bit of entertainment in the morning. So happy Friday, everybody. So I did not have a sign-in sheet for you today. So if you are having iClicker problems, you need to see me after class. If you're on Zoom, you need to connect with me after class. But by now, iClicker should be working for everyone. I think it is. So if it's not, you need to contact me. All right, let's see. We have a few iClicker questions to get us rolling this morning. You got this. All right, let's see. Which one is it? We did, I want to go past it. We did these. Okay, here we go. View full screen. All right, So I'm going to stop this poll. We have 41 in class today. All right. So remember, a minute and a half. How many neutrons are in an atom of oxygen 18? My chat back up. Just remember, a minute and a half. Okay, 10 seconds. Okay, so oxygen 18. How do I figure that out for oxygen 18? I like to write my little symbol. So what does the 18 tell me?
I'm sorry. I'm sorry.
It's okay.
I can't make start, but
It's okay. So what does 18 tell us?
can I go back to the I click our attendance thing?
It's okay. You'll check in. Even when you answer questions, you'll check in. It'll be okay. So AT goes on top or bottom? Goes on top. What goes on the bottom? 8. So 18 minus 8 gives me 10. So this is my protons plus neutrons. This is my protons only. So this is my neutrons only. So how many neutrons are 10? So what do we get?
Did it like populate the question?
What do you mean it didn't
Like,
populate?
when you click stop, it came up, so I couldn't put an answer because it didn't go to number 2.
Have you closed your app since you've used it last? Like swipe it up and get rid of it
Yeah, just,
and then re-enter it?
yeah, like I just did it whenever I got into class. I put it over and typed in,
Uh-huh.
and then I guess like when it blocked, it never.
I don't know. So that's why 70% is an A, so that we can have some technical issues and it's okay. So that's why we always do 70% is an A. So let's see how the next one does for you. Okay. How many protons are in an atom of nitrogen 15? Nitrogen 15.
Where do I check in at?
You don't have to. When you answer a clicker question, it's going to automatically check you in.
I just can't make start though.
That's okay. It's pretty empty on a Friday, huh? It's not a good sign, but it's okay.
It worked too. I guess it just
It worked.
didn't refresh when it locked. I'm gonna unlock my phone.
Phone.
It didn't have.
So
a phone.
maybe put your phone on like lock after like 3 minutes because you know it's going to be a minute and a half, you know, so it doesn't automatically lock on you. It's a good advice. Yeah, like
I'll have modern ones so it might be more-
there you go. There you go. So good tips and tricks. I like that y'all share with each other because I don't have the device. I'm not actually doing it. All right, 10 seconds. Ooh, we're up to 43. Okay, so nitrogen 15. 15 is our protons plus our neutrons. How many protons do we have in nitrogen? 7. So 15 minus 7 is? Oh, I'm doing, it is. How many protons? I'm chit-chatting with y'all. This is protons. It is 8 neutrons. Ooh, if I can, it is a neutrons. It's like the pen's not picking me up today. But it is 7 protons. I'm chit-chatting, I'm not looking at the question. Okay, so what did we get? B, good. Y'all were paying attention, just me that wasn't. All right, one more, y'all ready? Here we go. What is the least abundant isotope of, oh, I gave you the answer. How did I do that? Oh, man. Okay, so if we were gonna do this one, what's the least abundant isotope of calcium on Earth? What you do is, because you'll have something like this on the exam, you will. So look at your different isotopes, right? When we look at those isotopes, you can tell what the most abundant is 2 ways. If you're given the natural abundance, if you're given the percent, right? I can look at this and I can say calcium 40 is the most abundant and calcium 43 is the least. So this is most, this is least, right? What's another way that I could do that? Right, so look on the periodic table. What is calcium's atomic mass? Atomic mass is 40.08. Okay, so which one is going to be the most abundant? What could you answer that way? 40. What's closest to 40.08? 40. So 40 is going to be the most abundant. You can't necessarily answer what is least abundant unless I give you this percentage, but I can ask you what is the most abundant. Yeah? Okay. All right. Well, sorry I messed that one up for y'all. Maybe we'll catch up with a few more at the end. Okay. So let's go back to our in-class problems. Switching gears. All right. We did, okay, so it should be right here, right? Radioactivity and relationships. This is fun stuff. This is really cool stuff. Okay, so before we kind of answer some of these questions, I really want to just talk about it. If I can make it go away. All right. So there are different things that happen when an atom becomes unstable, right? There are a lot of different ways that that atom can return to a stable state. There are some elements that have isotopes that are naturally radioactive, so they're naturally unstable and they're unhappy with the arrangement of protons and neutrons inside their nucleus. They're really not happy. And so in order to revert back to a stable state, they're going to emit something. They're going to get rid of something. And these are the different ways that that can happen. So there are some isotopes that are naturally radioactive, like we mine for uranium, right? Y'all have heard that before. But there are a lot that we can build in the lab. We can actually make radioactive particles and use them in medicine. So how do we use radioactive particles in medicine? There are a couple of different ways. What's the most common? Cancer treatment. Cancer treatment. So this is super applicable and really important for y'all to understand how it kind of works. So let's talk about the different kinds of emission real quick. So if you emit what's called an alpha particle, so you have an unstable nucleus and you emit an alpha particle. An alpha particle, you can use the little alpha symbol, but that's not really helpful to anyone, right? It doesn't tell you what is inside of that particle. So an alpha particle is like a helium nucleus. What subatomic particles are found in the nucleus? Protons and neutrons, right? So look at helium on the periodic table. Tell me how many protons are in helium? 2, right? And if this is helium-4, because I have a little symbol up here, how many neutrons do I have? 2. So I can write an alpha particle as a helium nucleus, writing it as helium, a 4 on top and a 2 on the bottom. That tells me that bottom number is my number of protons, right? Top number is protons plus neutrons. That bottom number tells me that I have 2 positively charged particles. What's the charge on a neutron? Neutral. So what is my total charge for an alpha particle? positive 2. That's where we get it from. If you understand where the charge comes from, your math is going to work out. But then it has a mass number of 4 because we have 2 protons and 2 neutrons. So look at a beta particle. A beta particle is a little bit different. So what could you tell me about what's in a beta particle? We have an electron, right? How did you know it's an electron? So we have a negative charge, but I thought electrons didn't carry a charge, didn't carry a mass, right? So usually that's the place where we put a proton. So this is what happens inside of a radioactive element that's going to undergo beta emission. You actually have a neutron. And the reason you're unstable is because you have basically like the wrong number of neutrons. So you have this neutron that is going to eject an electron. I know that sounds kind of weird, right? But it's a neutron that ejects an electron. When that neutron ejects the electron, it is going to convert and become a proton. And the thing that you emit, the thing that you're emitting that's a -1 charge is really an electron, a high energy electron, electron, which means that it has a mass of 0. But because we have a neutron that's becoming a proton, the charge is going to change inside of that atom, right? And so we're going to write some equations and it's going to make sense then. So I want you to keep coming back to this table, all right? So the next one is a gamma. What do you notice about gamma? It's no charge, there's no mass. How's that possible? It's not a particle. It's just high energy light waves. High energy waves. So it's not a particle. So gamma radiation is really dangerous. I know I say it's not a particle. You know, it makes it sound less than something, but it's actually really, really dangerous. It's similar sort of to X-rays, but X-rays don't come from the nucleus. But it's similar in that it's waves of electromagnetic radiation, right? It's not a particle. So we put 0, 0, charge 0, 0. Okay, how about a positron? A positron is going to be an atom where we have a proton, and that proton is going to get converted to a neutron. And when that happens, you emit a positron. A positron is very, very similar to an electron, except it has an opposite charge. So what's the charge on an electron? -1. What's the opposite of -1? +1. So that's why we put it as an E, because it's similar to an electron, but it's positive. So the only difference in the beta symbol, see the beta symbol here, and the positron symbol, what's different? Just one's negative, one's positive. Positron's positive, electron's negative. All right, and then a neutron. So a neutron is typically not something that is ejected. Typically, we're scientists and we take neutrons and we shoot atoms with neutrons and we turn them into radioactive isotopes. And so this is how we generate radioactive isotopes. So we're adding usually a neutron, right? So it has a charge of 0 and a mass of 1. All right, so use your table up above. What is the charge on a beta particle? Go up, find your beta particle. Here's your beta particle. What's the charge? -1. What's the charge on an alpha particle? +2, because we have 2 protons, so we have a +2. And a positron? +1. Okay. All right. So which form of ionizing radiation is most similar to X-ray radiation and how is it different? What did we just say? Gamma radiation. Come on. Okay. Is most similar. Why is it similar? Because you have no particle, right? It's no, this is no particle. It sounds like my audio, like there's a little bit of feedback or something going on. But how is it different? I'm telling you, I do not want to get hit with gamma radiation. I don't. But I've had an X-ray before. Most people have probably either had an X-ray or know someone who's had an X-ray. So is it dangerous to go get an X-ray? If you get too many. So if you're an X-ray technician, yes, you need to worry about it. But in your lifetime, it's probably going to be okay, right? So tell me, which one is more dangerous, gamma or X-rays? Absolutely gamma. So gamma is higher energy. Gamma is higher energy. I feel like I'm at the bottom. I need to, oh, I can't scroll up. That's why. Let me extend the page. Yes, ma'am.
So like, what would expose you to gamma radiation?
Higher E and ER. So if you come into contact with a radioactive isotope that is emitting gamma radiation. So I'll tell y'all, I used to work in a lab and we used radioactive materials in our science. You know, we can label things radioactively and track them and all this kind of stuff. And so I had to wear a lab coat with a little button that collected how much radiation I was collecting in my lifetime, right? And so like if I go and work in another lab where I'm doing any kind of radiation, anything, they'll give me a new badge, but it's in a system with my social security number. So it'll track me no matter where I go. So if you are treating someone with cancer, sometimes there are some that emit gamma radiation. Sometimes it's in science, sometimes it's if you're designing a weapon. I mean, you know, there are lots of applications for it.
And see people who like get the radiation for cancer, can't they admit that to other people as well?
So you can, but there are different, each kind of radiation can get through a different amount of material and type of material. So gamma radiation's really not good for you, but if you have a simple barrier that's the right material, you can protect yourself completely, right? So a lot of times when we give people radioactive material, what we want to do, this is really important, is we want to give them radioactive material that has a very, very short half-life. So a half-life is, you know, in like 1 hour, if you were given 1 milligram, you end up with half of that. So you have half a milligram inside of you. So there are radioactive isotopes in nature that have a half-life of millions of years, right? That's not what we want to give our patients. We want to give our patients something that has a half-life of a half an hour, right? So that they don't take that home and expose somebody else and that kind of stuff. So that's a really great question. Yeah, and we're going to talk lots about half-lives. We will. You want to or not. All right, so if high doses of radiation can be harmful, that's what we just said, right? What's the rationale behind radiation therapy for people with cancer? Why do we want to give it to them? Why does it affect the bad cells and not the good cells? It affects them both. It affects them both. So radiation.
But it affects the cells that produce more quickly.
Yes, affect all cells, right? All cells. But cells that divide more rapidly consume more nutrients. The more you eat, the more radiation you're taking in. So rapidly dividing cells take in more radiation. So are cancer cells rapidly dividing cells? Absolutely. Are they the only rapidly dividing cells in our body? Oh, problem. Y'all tell me, what are some of the common side effects of radiation therapy? Stomach lining, your hair. Sometimes people have skin and nausea and vomiting, right? So when you think about that, right, your stomach is containing acid. And so you produce mucus lining to separate your cells from that acid. But if you give someone radiation, it's going to kill those rapidly dividing cells, and they're no longer going to produce as much mucus. It's not going to protect the stomach. They're going to basically feel the effects of their stomach acid, and they're going to be nauseous. Same thing with hair. Hair is rapidly dividing. Radiation is going to go to those cells that rapidly divide, and that's why people lose their hair. So all the symptoms of chemotherapy and radiation and things like that are all because those are also rapidly dividing cells that are affected. Okay. All right, here's a good one. This is what we were talking about just a second ago. Excuse me. How many simultaneous X-rays would a person have to endure to have an exposure of 20,000 milliriems? Now, 20,000 milliriems, if you look in your book, right, there was a table, and it kind of showed you how many milliriems until, you know, you start to feel whatever effects, and then it starts to get to a lethal dose. What's the lethal? When they do LD 50, what does that mean? This is the lethal dose where 50% of the people who are exposed will die. So that's like when you're getting really, really high levels of it, right? But what we're saying is 20,000 milliriems is less of an exposure, but it will cause a temporary decrease in your white blood cell count. So how do we set this up? What should we do? So 20,000 times some number, right? So that would be our number of X-rays we would have to get. Equals what? So we're missing a piece of information, right? What piece of information are we missing? How much radiation you would get in a chest X-ray, right? So if you looked in the previous one, right, a dental exam is X-rays exposing you to 5 milliriems. That's a smaller area. A chest X-ray is a bigger area. So a chest X-ray is about 10 milliriems per X-ray. So really, how should we set this up? We want to know how many, so X times 10 milliriems will give us 20,000, right? So divide 20,000 by 10. How many do you have to get? You need a calculator. How many X-rays do we need? 2,000 X-rays. Anybody planning on getting 2,000 X-rays in here? No. But what if you're an X-ray technician? You think in your career you would do 20,000 X-rays? Absolutely, probably more. So that's why X-ray technicians will leave the room, right? Or they'll wear that lead apron, you know, whatever it is. And it's not that they want to protect the technician and not you. It's that the technician is going to be exposed a whole lot more than you will be because they have to do it so many times. Okay. All right. Oh, we did this in the video. Awesome. Oh, we did it all in the video? Oh, I forgot. All right. Oh, but I did mess up on this, right? I did mess up on this. Y'all did notice this. Yep. Like, this is, no, she's wrong. She's wrong. Well, it was C and C, and I don't know how I did that, but it was the carbon 11 and californium 251. So in the video, I did A, B, C on 2.29, and then I jumped down for some odd reason and did D. So make sure you have that correct in your notes. So what I want to do first is we're going to go pick up this number D right here. So everybody, okay. And y'all, please let me know when I do stuff like that. I can do crazy things. All right, so D, we have carbon 11. So our 11 is going to go on top. Go look on your periodic table. 6 is going to go on bottom. Okay, it's undergoing positron emission. So what happens in positron emission? Positron emission, we're emitting it. We're getting rid of it. So what are we doing? This is what we're starting out with. We're starting out with carbon 11, and it's going to produce two things. Whatever is emitted and whatever is left, right? Okay, so what was emitted? A positron, be careful, a positron. So what's the symbol for a positron? 0 and a 1. But make sure you do not put the negative sign. Okay. Now, our problem is we got to figure out what is left. So it's like a math equation. The top and the bottom is just like a math equation. Everything on the left-hand side at the top needs to add up to everything on the right-hand side at the top. Same thing at the bottom. So don't try to fill in your symbols until you do the numbers first. So look at the top. If I have an equal sign here, right? 11 is equal to 0 plus what? 11. 6 is equal to 1 plus 5. All right, now look on your periodic table. Am I looking for something that has a 5 or an 11? A 5, good, awesome. So which element has a 5? Boron. Y'all are so good at that. Ooh, trying to erase. Okay, good. Yes. How did I get the 5? So I'm looking here at the bottom, right? I have 6 on the left. So this is like my two sides of the equation, just like balancing a chemical equation, right? So if I have 6 here, I need to make sure that this and this equal to 6. So I add them together. You just like think about like a just algebra equation. 6 plus, oh, 6 plus, so sorry. 6 equals 1 plus X, right? And you're trying to figure out what is X. It's the same thing. Yeah. Okay. Get myself some more room. See, I think I was able to change the line size. Can y'all still see it if I do kind of a thinner line and I'll have a little more room? That'd be okay? Y'all tell me if it's too thin. Okay. All right, let's try this. Okay. Did I do black? Probably not. No, I didn't. All right. Now we're gonna rock and roll. Okay. B, strontium 92. What's the symbol for strontium? SR. SR. But I think I need to go up a little bit. We're getting towards the bottom. Oh. Because I'm thinking we did, y'all. Because I'm thinking D was A. So I'm sorry. Let's do A first. Let's do A first. Okay. Thorium 232. What is thorium? TH. 232, top or bottom? Top. 232. Okay, undergoing alpha decay. So it's going to make two different things. It's going to make an alpha particle and it's going to make something else. So what is an alpha particle? It's 4 on top, 2. Now, what are the two different things that you could write here? You could write either helium or you could write alpha. But to me, it makes more sense to write helium. It doesn't matter to me, but okay. Now, what else can we fill in on this? We can fill in the atomic number on thorium. What's the atomic number on thorium? Okay. And how'd you get that? We just went to the periodic table. Good. Okay, so now do your math. 232 is equal to 4 plus what? Okay, good. All right, 90 is equal to 2 plus what? 88. Okay, so now what do I do? Go look on the periodic table and find out where we have something that has 88 protons, and that's radium. Good? All right. So let's now do B. See, oh, every time you would have to change it. Oh, that's too much of a pain. Okay. Strontium, now strontium. SR. And we know the 92 goes on top. What goes on bottom? 38. Okay, it undergoes beta decay. What is beta decay? So this is just an electron, right? That's an electron. So you could put the E or you could put the beta like that, either one. Beta, instead of a regular old B, a beta has like an extra, that stick goes down a little bit further. But to me, it makes more sense. You know it's an electron. So what's my mass of an electron? 0. Charge? -1. Okay. Now be careful with that negative in predicting what your product is going to be. So let's do the top. 92 plus 0 is 92. All right, now 38 is equal to -1 plus what? 39. Y'all saw that? Be careful with that one. So what element? Y is yttrium. Okay. A, B. So we still got to do C, right? Okay. All right. So C. We have nitrogen 13. And it is undergoing a positron emission. So what's my other part of nitrogen? 7. Now we have a positron emission. What's a positron? It's an electron, 0, and a 1. It looks just like an electron, except it is positive. Okay, so 13 is equal to 0 plus 7 is equal to 1 plus 6. Y'all got this. So what is this? Carbon. Pretty cool? Yeah. All right. Now, these were all decay, right? Decay or emission are the same thing. What happens when we switch and we say production? It's a little bit different, right? So we're going to produce iodine 131 used in the treatment of some cancers from the beta decay of tellurium 131. So which side of my equation is iodine going to go on? Iodine's going to go on my right. So iodine 131. And so where's tellurium going to go? Left or right? Left. So what's the symbol? Te 131. And do we know what else is being produced? We know it's beta decay. So where does the beta go, left or right? It's right. It's right. So because we're saying it's the beta decay of tellurium. So here's the original substance, tellurium. Tellurium is going to decay into iodine and a beta particle. So be careful that you know which side of the equation to put it on. Sometimes that's a little bit tricky. So a beta particle, y'all told me already, was just an electron. What are we missing? Atomic numbers. But here, did we have to do any math? No, it was just knowing which side of the equation to put it on. So, okay, so for tellurium, what's my atomic number? 52. And for iodine, I have and one nice thing about this, if you go and get your atomic numbers off the periodic table, you can check your setup. You can, and the math from the top and the bottom should work out correctly. If it does not work out correctly, you put something on the wrong side. So it's a good, like, double check, did I do it right? All right, how are we doing on time? I forgot my watch today. I got no clock over here. 10:40, so we, 10:20. Okay, so we still got 20 minutes. We still good. We rocking and rolling. We doing good. Okay, so we're gonna go on to radiation and half-lives. So I know you probably haven't not watched the videos for this. Ooh, let's go pick up some clicker questions. Let's go pick up some clicker questions. Hang on. We're gonna do that. So that, yes, let's do that. So that we're not out of order. I'd rather pick up some more clicker questions because we just did it. It's fresh in your mind. Okay, y'all ready? Keep your work out so that you can use it to help you answer. Okay, everybody ready? No, not everybody's ready. Y'all can say no, it's okay. Take a deep breath. Okay. All right, you ready? Okay. Hopefully I didn't give away any more answers. All right, so I'm gonna move this down. So I'm gonna give y'all 3 minutes. Have a piece of paper out, write this down. Okay, so I'll give you 3 minutes and we'll see how many people have checked in by then. All right. So what daughter nucleus results when a radon 222 undergoes alpha decay? Samantha, you having trouble getting in iClicker? Hmm? Well, are you, but there might be multiple Samanthas. No, if you didn't text into the, type into the chat. Okay.
Which one is, wait, which one is radon? Radon? Oh yeah, this one, radon, right?
So we got about 15 seconds left. I'm gonna give y'all another 30 seconds. So 3 minutes and 30 seconds, and then I'm cutting it off right there. Okay, 10 seconds. If you haven't checked in, take a guess. Okay, so let's do the problem and then we'll check everybody's answers, right? Okay, so radon, what's the symbol for radon? RN. What is it? 222, and what's on the top? 86. Okay, it's going to undergo alpha decay. So an alpha particle is a helium nucleus. So what goes on top? What goes on bottom? 2. All right, let's do our math problem. 22 is equal to 4 plus what? 18. And then 86 is equal to 2 plus what? 84. So what element has 84 protons? Polonium. So what should your answer have been? E. D. No, E. E. Like, what am I looking at? E. So when we give a name, right? If I would say polonium 84, that's telling me that I have 84 protons. Would that tell me anything about an isotope? No. But if I say I have 218 protons plus neutrons, what can everybody in this room do? Everybody can go to the periodic table and find what? That polonium has 84 protons, right? Then you can calculate the number of neutrons. So when you select one, make sure that you're selecting the one where the number on top is after the word, okay? What daughter nucleus results?
Yeah.
But a nucleus, what's in?
I knew it was polonium, and I couldn't figure out if it was 84 or 218.
Right. But if you were just given 84, that's not giving you anything more than what's already on the periodic table.
Right.
So it doesn't help you to know especially about isotopes. Yeah. But what's in the nucleus? We know neutrons and protons. Okay. Ready to try one more? Y'all got this. Y'all got this. Okay. Here we go. So I gave y'all 3.5 minutes. I'm going to give you 4 minutes, and then I'm going to cut it off at 4 minutes. I'm not going to give extra time. It's going to be 4 minutes. All right. What daughter nucleus results when carbon 14 undergoes beta decay? So remember, 4 minutes. Should have said 3.5. Okay. 30 seconds. And I think once you click in, if you change your mind, you can change your answer, if I remember correctly. As long as the timer's still running.
So thank goodness. Because you look back and you're like, no.
Absolutely, it's a good thing to be able to do, you know? And or if you like accidentally touch the wrong button, you know? All right. So we have carbon 14 and it's undergoing beta decay. So what's my my atomic number for carbon? 6. What's beta decay? -1, and we represent that either with an E or as a beta 0, -1. Either one's correct. All right, so look across the top. 14 is equal to 0 plus what? 14. 6 is equal to -1 plus what? 7. Whoa. Technology, man. All right, 7. I promise I'm not that bad at penmanship. Okay, so what is 7? What has 7 protons? Nitrogen. Nitrogen. So which answer choice is correct? A. And y'all would have gotten it correct if this nitrogen had been 7, right? I still would have gotten it correct. Because that'll probably be an answer choice on an exam. Make sure you know which number goes at the end of the element name. Okay. All right. I am going to stop there. Any problems with the online system entering in?
Do you have to read on your QR code?
Oh, yeah. Thank you. Thank you. Yeah, I can go back and do it. If I ever forget, I can go back and do it. Y'all just send me an email. Dr. B, you forgot to like grade the last one or whatever it was, and I can fix it. So yeah. All right. If you have any iClicker issues, you need to see me today. And you should almost be able to finish all of the homework on MyLab and Mastery, right? Because we have 2 little sections left. And then exam next Wednesday. Yes. You got this. You got this. Sure. What's the question about your exam?
You say what you're giving us is the periodic table and all the.
The exam, so if you go on Moodle and you go to exam resources, you'll see exactly what you're given.
Right. So what you gave us today was the whole beta, alpha, all that needs to be memorized.
For the last 2 questions, I didn't even know my iPad was off, and I put the answer, but it didn't send me. Is that all right?
Wait, for the first and last 2.
For the last 2 questions, I thought my iPad was on, but it was off, and I clicked the button, and I noticed the answer.
Oh no.
I kind of knew the answer.
Well, that's why 70% is an A. So you don't actually have to make an A to get an A, because like stuff like that's going to happen, you know.
Yeah, I know.
So
That's cool. I guess.
So, like, you're gonna have lots of opportunities. Like, and the difference now probably looks big, but by the time we get to the end of the semester, we're gonna have 4 or 5 clicker questions every single day.
Yeah, so it's gonna add up. Huh?
It's so gonna add up.
All right.
So don't stress.
I'm gonna stick. I ain't stressing about it.
Good.
So our first homework was Tuesday, and so I looked at my calendar, and like a friend and I that did it together, we were like once we looked, we were like, okay, on the app, like on mastering and AMP, we had like 95s because like we completed most of the work, and then on the homework on the grade and middle, it said we had 53. And so I was wondering how you graded.
It's just no. So I pull it every so often. I pull it and it's going to update, but it's going to take exactly what you have in every single homework at the time that I pull it.
Okay.
So if you started on the next one and you're already halfway through it, when I pull it, the previous one is going to read 50% because you're halfway through it.
Okay.
So then when I pull the next one, then it's going to update to 100%. So what you have in MyLab and Mastery is what you have.
Okay, because I started like a couple things on the second homework, but
Yeah.
the first homework I had literally like 95.3 or something, and I was like,
So it should
If it only
completely
says
update.
100%
So I
of the
try to
homework.
sync after grades are due.
Okay.
So like if a homework is due,
So like once we
I'll
turn
pull
in
it the next
second
morning.
homework, the first one will update.
Yes.
Okay, so okay,
Yes.
okay.
Yes.
That literally.
so
took
if
my
it
mind
doesn't update after that,
Okay,
then tell me.
okay.
But you tell me.
Yes, okay, I will. Okay,
Okay.
thank you so much.
Yeah, sure. The same question.
I was wondering if the homework was going up.
Yeah, like
Is different from the.
No, it's the same, but like you were probably ahead of the game. That's probably what happened, right? So when everybody finished their homework, you already started on the next homework, and I pulled,
Okay.
and so then it says, well, you only partially completed this one,
Yeah.
right? But you didn't. So after the homework is due on Tuesday, no, Monday, no, it's due Tuesday. Then I'll pull it on Wednesday,
So then I'll go
and it'll
back.
update.
Okay,
Would you remind me in the next class to tell that to the whole class?
okay.
Because if y'all are thinking that, then like everybody's worried about that. Yeah, or post it. Yeah, and that's maybe what I need to do is just post it there.
Personal question, I
Oh,
didn't know, so I'll put it in another session.
awesome.
Okay, so 2 things. Tomorrow is starting to study and stress about next
Study's
week's
good,
test.
stuff's not so much.
So do you have, I have all the answers to the ones that you have some of the answers and I have some of the answers in my book. I don't have all of the answers.
Right,
So
right. You have
practice
the
questions.
odd numbers.
Right.
Yes.
Can I get the answers so that I can keep
Yeah, send me
practicing
which
that
ones you
stuff?
want.
Okay.
Send me
because,
which
like,
ones you want
I've
the
just
answers
started
to.
going through all of them and just like working everything again.
Yeah.
And I'm so bad at it that they all look new again. So it's like, oh yeah, oh wait, no, yeah.
So
maybe.
how are you doing on the odd ones?
I'm doing okay, but I always double guess myself. Like I always want extra work. I always want
To make sure that.
doubly sure that whatever, so all the extra work that I can get, I really like because it cements it in.
Yeah. So send me the ones you want to check the answers to, and I'll send them to
Okay,
you.
so like, yeah, the ones that I was having trouble with
Oh
was,
no, I saved that. Oh well, it's fine.
the ones that I was having trouble with was all the conversion stuff because I didn't get it first go round. I got that much later